Okay, so now let's explain my solutions for the practice list. So the first two questions, they said expand each log expressions. So expand means we will write one log to several logs, right? So it looks like number 4. In your answer, you have 3 log expressions. So we have 3 properties about log. We have a product rule, we have a quotient rule, and we have a power rule. So in the beginning of number 3 and number 4, these two questions, we use quotient rule. Okay, quotient rule. So number 3, log 5, 25 over x squared. So it's a quotient. So we use the quotient rule, the second rule here. So log m over n is log m minus log n. So we have the same base. Log 5, 25 minus log 5 x squared. So we change the quotient to a subtraction. So that's step 1. And step 2, we can simplify log 5 of 25. So this is number 2 minus log 5 x squared. So the next step, we can use this power rule. Okay, because we have x squared, a power inside the log, the second power. Okay, the second power. So we can move this number 2 to the front. Then we get the answer 2 minus 2 times log 5x. Okay, so that's the first question here. The second question have the same beginning step. Log radical x over y cubed z. So first is a quotient, so we use rule number 2. So we change this to log radical x minus log y cubed z. Okay, so for radical x, we change it to rational power, half power. Okay, so now inside log we have a power, so we use power rule. We move 1/2 to the front. So we got 1/2 log x. So this is for the first part. So the second part is the multiplication. Log y cubed times z. So we use the first rule, product rule, this one. So m times n is log m plus log m, so it's addition. So we get the first part log cube plus the second part log z. And then this subtraction sign applied to 2 terms in the parentheses. So we got minus log y cubed minus log z. And then we use the power rule for this y cube. So 3 goes to the front, so we got 3 log y minus log z. Okay? Yeah, so next part. Okay, so this question is similar to the other two questions. First, we have to rewrite the given log expressions to log x and log b of x and log b of y. Okay, so that's called expand. First, we have to expand. Okay, so after you got the expansion, you can plug in, right? So after you got these steps, you can plug in log b of x is 5, so this is 2 times 5. Log b of y is 3, so this is 3 times 3. Okay, so here for this problem 6, x squared over y cubed, so it's a quotient. So we got this minus sign, quotient rule. And then these powers, instead log is the power rule. So we move 2 to the front, 3 to the front. And then we replace log b of x and log b of y by the given number. Then we get the answer. Okay, so number 5 is similar. So is radical x, so we get half power, and then we move it to the front. We get half log b of x, and then replace it, because log b of x is given is number 5, so we got 5 over 2. So this evaluation questions is application of the expansion question. So the next two part is condense each logarithm expression as a single log. So you are given several log expressions. In the answer, we want a single logarithm. Okay? Yeah, so we put several logs together. So that's the inverse of this function, right? We put log forms together. We go this way. If you have addition of logs, we got multiplication inside log. If you have subtraction of logs, we got a quotient in the log. So if you have a number times a log, you get a power inside the log. So it's the reverse of expansion. So for this question, first we have to get chain number 1 to a log form. Okay, so we use the same base. So for all these three formulas, we have to use the same base. So number 1 is log 3 of 3. So now we have same base 3. Subtraction implies a quotient. So it's 12 over 3 inside. We got log 3 of 4. So the answer is a single logarithm. Okay, yeah. So the other one, you have a multiplier. So a number times a log. So this is the power rule. A number times a log means we put this number to the exponent inside log. So 2, you will get x squared. 1/2, you got z to the half power. Okay, so we got 2 log x plus 1/2 log z. So first we move 2 and move 1/2 inside the log, so log x squared plus log z 1/2 power. And then this addition tells us we should use the first rule, the product rule. So addition means multiplication inside, so it's x squared times z to the half power. Okay, so we use these first three formulas to either expand or condense. So next part is change base. Okay, so we have to change the base of log. So what's the idea of change the base? So if you have log a of b, okay, so you will be given a new base. So for this particular question, they want common log. So that means base is 10. So we need a quotient, a log base 10, log over another log base 10. Okay, and then it's very easy. So b goes to the numerator, and this base a goes to denominator. So we have log 10 of b over log 10 of a. Okay, so if they want the new base to be 10, so if you want new base to be e, natural log, right? So this is ln b over ln a. Okay, again, so base goes to denominator, this power goes to numerator. Okay, so you can see here, so if this is log 3 28, so log 3 of 28, so 3 goes to the bottom, so it's log 10 of 3, and 28 goes to the numerator, is log 10 of 28. Okay, so here is the same thing, so this is log 5 of 2 over 3. So the new base is 10, so we have log 10 of 5 in the denominator, log 10 of 2/3 in the numerator. So this is very easy. Okay, just put a in the bottom, b on the top for this formula. Okay, change base formula. So that's the properties of logs. Now let's talk about equations, exponential equations or log equations. So these two examples are easier. We don't need log because we can change two sides of the equation to same base. Okay, so for easier question, again, we want same base. So what's the property? If you have a to the m's power is equal to a to the n's power, so this implies m is equal to n. You can drop the base. Okay, you can drop the base. So now let's look at number 1. So 2 to the 2x is 8. So we can change 8 to the same base number 2. So we write 8 as 2 cubed. So now same base, we can drop base 2. We got a new equation. 2x is 3, so x is 3 over 2. Okay, so this case is very easy. You can change left hand side and right hand side of the equation to the same base. Number 2 is similar. 5 to the x is 1 over 25. So we need base 5 on the right hand side. So 25 is 5 to the second power. 1 over that, you got 5 to the negative 2's power. And then you can drop the same base number 5. So x is negative 2. So this is a very easy case of exponential equation. For the next two examples, you cannot change left hand side and the right hand side to the same base in exponential form. So you have to use log. Okay, you have to use log, and basically is the definition of log. Okay, use the definition of log if you cannot change two sides of the equation of exponential equation to the same base. So let's look at the left example. So 2 times e 3x minus 1's power is 2. So first we have to isolate this power. So divide by 2, divide by 2. We got e 3x minus 1's power is 1. Okay, yeah. So if you realize 1 is e to the 0's power, you can change this to the same base and then you get the answer. If you didn't realize that, you can change this to a log notation. Means log base e 3x minus 1. So that's the exponent and then power 1. Okay, so we change exponential form to log form. So 0 is 3x minus 1 plus 1 plus 1. You got 1 is 3x, x is 1/3. Okay, so you can use log. The other one, 5, 3 minus x is 63. So you cannot change 63 to a power of 5. Right? 5 squared, 25, 5 cubed, 125 is too big. Then we use log notations. So we change it to log. Log base 5, exponent 3 minus x, and then power inside. So after changing to log, you can check it, right? Check it this way. Rate it counterclockwise or clockwise. Okay, yeah. So now don't worry about this bad expression, log 5 of 63. It's just a number. Okay, it's just a number. You don't have to simplify a number. So now what is x? Okay, what is x? So you can move 3 minus 3 minus 3 divided by negative 1, or you can move x and move this number, right? So if you move x to the left, negative x become positive x. You move log 5 of 63 to the right, you got negative log 5 of 63. Okay, yeah. So this is the harder case. You use definition of log to solve exponential equation. Next question. So we want to solve for x. Log 6 of x is 2. So this is just the easiest case of log equations. It's just the definition, right? Definition. So this means 6 squared is x. So 36 is x. Okay? Yeah. So number 8, log x of 16 is 2. So again, you just need definition to solve this log equation. This means x squared is 16. So x could be positive 4 or x could be negative 4. But we have to drop the negative solution. Drop this solution. Okay? Because in the definition of log, if you have log a of m, so we assume they are both positive. Okay? They are both positive. So that's why for some log equations you have to check your answer. Okay? So positive 4 here is okay, negative 4 is wrong because the base cannot be negative. a little bit harder question. Okay, a little bit harder example. Log 2 of x minus 5 is -1. So again, first we use definition of log. So 2 to the -1's power is x minus 5. So 2 to the -1's power is 1/2. So 1/2 is x minus 5. 10 plus 5 plus 5. You got x is 5 and 1/2. Okay? Yeah. It's just a definition. Ln radical x is 2. Solve for x. Okay, solve for x. So first we put the base e back. And then we use definition. So e to the second power is radical x. So now what's x? Square both sides, right? Because this is radical x. You want x. So just square both sides. So we got x on the right hand side. So e to the power of a power formula, so it's 2 times 2. E to the 4th power is x. Okay, so definition of log is the most important part. Question 11. Log 4x minus 3 is log 2x plus 5. Okay? So you are given log on both sides of the equation. So I wrote down one-to-one property. For log. So what's one-to-one property? If you have log a of m is equal to log b of n, same base. Okay, again, same base. Then you can drop the log part. You got m is equal to n. Okay, m is equal to n. Okay, so now for this particular question, we can drop log base 10, common log. So we got 4x minus 3 is 2x plus 5. Solve this linear equation. You got x is 4. So the most important thing is you have to check your solution. How to check it? You make sure you take log of positive numbers, right? Base b has to be positive, m has to be positive. So you plug in 4 here. Base is 10, you don't need to check it. You just check these two parts instead log, they're positive. 4x minus 3 if x is 4. So this is 16 minus that, 13 positive, so it's okay. 2x plus 5 is 2 times 4 plus 5 is 13 again, positive. Then this is the right answer. Okay, you have to check your answer for every log. Make sure base is positive, the power inside log notation is positive. Question 12. Log 2 of 3 minus x plus log 2 of 3 is log 2 of x. Okay? Yeah. So first we have to put these two logs together, right? Addition means multiplication, so it's the inverse of product rule. 3x minus x times 3 is log 2 of x. So now one-to-one property. Log with same base, you can drop it. Okay? Yeah. If you have one log form on the left, one log form on the right, and they have the same base, you can drop the log part. Then we got a new equation, 3 minus x times 3 is x. That's a linear equation. So 9 over 4 is the solution. Okay, is the solution. And you have to check it, right? Make sure you take log of positive numbers. So if x is -4, is 9 over 4, so this is okay, right? This is positive, this is positive. And then this one you don't need to check. 3 minus x, so 3 minus x is 3 minus 9 over 4 is 3 over 4, positive. So this is a good answer. Okay, this is a good answer. The next one, right? The next one, longer one. log 2 of x minus 6 plus log 2 of x minus 4 minus log 2 of x is 2. We have 3 logs on the left. Okay, on the left. So we have to put them together using product and quotient rule. So first is product rule. We got log 2 x minus 6 times x minus 4. And then this subtraction is the quotient rule. Right? So here is product rule. Because it's addition, subtraction is quotient rule. So we put over x in the bottom. The other side we get number 2. So if the other side we have log, we can drop it. Now we have a number on the other side. So what's our idea? We just use definition of log, right? X minus 6, x minus 4 over x is 2 to the second power. Okay, so we read this way, right? 2 squared is this complicated expression. Okay, and then you solve it. Solve this one, you got 2 solutions. So I skip the solving part. Okay, you can read my PDF file. So x1 is 2, x2 is 12. Okay, x2 is 12. The most important step is you have to check them. Check these 2 numbers. Okay, so we have to delete this answer. We have to delete number 2 because if x is 2, then log 2 of x minus 6 is log 2 of 2 minus 6 here is negative 4. So you cannot take log of a negative number. So this solution has to be deleted. This one is okay. When x is 12, this is positive. The first one positive, second one is positive, and the last one is positive. So all these 3 things on top in the beginning is positive if x is 2. So this is the only answer, number 12. So I have 2 more examples in my practice list. Okay, practice list. Because I want to explain this checking step and the inverse function. So last 2 examples. Log 2 of x plus log 2 of x minus 1 is 1. So again, this is the product rule. So log 2 x times x minus 1 is 1. So now definition, right? Definition of log. We got 2 to the first power is this x times x minus 1. Solve this quadratic equation. We got x1 is 2, x2 is negative 1. And check it, right? Check it. So when x1 is 2, log 2 of x, okay. Log 2 x minus 1, okay, right? So this is positive, positive. So when x is negative 1, this is wrong. Log 2 of x will be log 2 of negative 1. So you have to drop this solution, okay? Drop this solution. So after you solve a log equation, you have to check the beginning log notations, okay? You're taking log with a positive base of a positive number. This is the most important thing for log equation. The last one is the inverse function. So a lot of students didn't do good for the inverse function, right? So let's find the inverse function of this 2 to the 3x minus 5 power. Okay, so step 1, we change fx to y, right? Change fx to y. So we got y is 2 to the 3x minus 5 power. And then we rewrite it to log. So this is means log form, right? So log base 2. This is the exponent. So the whole thing 3x minus 5 is on the right hand side. Okay, so this is 3. And then the power y is inside. So 2 to this power is y. Okay, you can check it after you write down the log notation. Yeah. So solve for x is step 3, right? Step 3, solve for x. So move 5, we got log 2 of y plus 5 is 3x, and then divide by 3. You got the inverse function. Okay, inverse function. So if you want, you can also change this x back to f inverse y, but I'm going to skip it here. Okay, you can use all these solutions to prepare to work on your quiz 3 by yourself. Okay, again, by yourself. Don't copy others, and don't ask your friend or tutors.